Algebra 1, lesson 114, page 479. I better look and see what this is actually called. This is called exponential key, exponential growth, using the graphing calculator to graph exponential functions. Now, y'all don't have a graphing calculator, and I don't care if you have one. I really don't even know how to use one, but I'm going to show you how to do what they do with your normal calculator. Okay, so you don't have to have a graphing calculator for this. And even if you did, I'm not sure I could teach you how to use it. Number one, though, is the exponent key. This depends on your calculator. I have a Texas Instruments, an old one here, 30, 36, okay? In my calculator, I have first function in x, y to the x key. So if I want to do, let's see, if I want to do in here, how do I do this? Let's see, turn it on first. That's always a good thing, clear it. So if I go 4, x, y, 3. So what I did was 4 to the third. That's all right, 4, third. Yeah, I did 5 to the third. 4 to the third. So I just put in to do this. I hit 4, this button, 3, this button. Let me just see. I think that's the way I did it anyway. So I go 4, x, y, 5 equals. There you go. So I put in 4, first function this, 3 equals, and it gives me the answer. If I want to take a root, like a fourth root of something, okay, I have to go to the second function. Same key, but right over it. I hit second function to come down to that key. So that's one, let's see, one I know. So let's see if I can do this. 125, second function, x, y, 5 equals, nope, did it wrong. 125, so let's do 3, second function, x, y, 125 equals. Even worse. 5, third equals 125. So 120, so let's try this. Second function, 125. So try it again. Second function, 120. I can't hit the 1. Clear it all out. Okay, second function, 125 x, y, 5 equals. Wow, this is crazy. 125, second function, 5. Oh, I can't remember how to use my calculator now. Second function, 1, no. Second function, 5. What in the world? 5, second function, 125. Let's say 5, second function. I have not used this calculator much before, so I can't remember how to do it. You have to enter the x first. I don't know. In your calculator, you're going to have to play with it. I can't remember how to do this on this calculator. I've never tried to do it before, so I'd have to play with it and play with it and play with it to figure out how to do it. One to check is do this. That's why I'm getting the numbers wrong. Okay, because I'm retarded. Let me just try that. In my mind, I was doing something else. So let's see. 125, second function, x, y, 3 equals. There it is. So I hit in 125, second function, this key, 3 equals, and it gives me the answer. Y'all's calculators work however they work. If sometimes you have this instead of that. This little arrow is the same thing here. You put in the, I don't know, the x first, this, the y, and it tells you. You have to play with one you know, like this, to make sure you're getting the right answer. I don't know. Some calculators you put in the y first, this, and then the x, like 64, 4, this, and then 3, and you get 64. Some calculators you do it the other way around. You just have to figure out how your calculator works. Same thing, to get a root of some number, like this, you're going to have to play with your calculator to see how it works. It may be that you hit 125, second function, this key, 3 equals, and it gives you the answer. Or it could be the other way around. You just have to see. But these are the higher order power and roots on a calculator. Second function is the one right above it. Okay? And again, your calculators work differently. So they do the same thing. You just have to figure out how to enter the numbers. You play with it. I'm not interested. Okay? So we're going to graph this function. Now, we've been graphing things. What we've been graphing is this. Y equals x squared. When you put it in the graph, it looks like this. Okay? If you add something inside here, moves it left, right, up, down, you got all that. This is not that. Okay? This is a number to a variable power. Okay? So what you have to do is you're going to have to do the XY chart. The answer you get out is right here. The answer, the thing you put in is right there. So to right here, we have 2 to the negative 3. You make that a positive exponent. 1 over 2 to the 3 is 1 over 8. So this is 1/8 right here. Okay? And we put a negative 2 in there. That's going to be 1/4. Again, you understand, negative exponent does not mean negative number, okay? If you put a negative 1 in there, that's just a 2. That's a 2. Wow, and I can't write for nothing. 2. If I put a 0 in here, anything to the 0 power is 1. 2 to the 1 power is 2. 2 squared is 4. 2 to the 3rd is 8. Now, do you notice anything here? The negative 3 is to the 1/8. It comes out as 1/8. Negative 2 is 1/4. Negative 1 should be, I didn't do that right, 1/2. My mind was in the right place, my body wasn't. Anything to the 0 power is 1. 2 to the 1st power is 2. 2 squared is 4. 2 to the 3rd is 8. Now, we're going to graph those. So, without a graphing calculator, this really is the only way to do this. And I'm not going to ask you to do a bazillion of these. But you got to do a couple just to kind of get a feel for it. So we're going negative 3. That's 1, 2, 3. And then we're going down an 1/8. It's right here. We're going negative 2, and we're going down a 1/4, which is a little bit more. We're going negative 1, and we're going down a 1/2. Oh, man, I better. So this is like almost on the line. This is like a little bit here. This is halfway down the line. 0, 1. 0, 1. Okay, you're starting to see the pattern here? 1. Now, we have 1. I'm sorry. We have 1 and 2. I lost my mind here, guys. Kick me, and I'll be okay. Negative 3 and 1/8 is just above the line. I apologize. Negative 2, we're a 1/4 above the line. Negative 1, we're halfway above the line. 0, we're on 1. On 1, we're on 2. On 2, we're on 4. 3, we're on, well, if we did it, 1, 2, 3, 4, 5, 6, 7, 8, it's about up here. Now, this is an exponential function. Okay, this is the graph of an exponential function. this is talking about like bacteria growth, population growth. It starts here almost on the line. It never gets to the line, okay? It never gets to be x is 0, y is 0, but it gets closer and closer. The bigger this number gets, the closer it gets to the line. Bigger this number gets, the smaller the fraction is, okay? The bigger this number is, the smaller the fraction is. So it starts here, and it comes up like this. Okay, this is a graph of this, exponential growth. If you had a 2 in here, it would change the slope of it a little bit. Okay, if you had a 3 right here. Okay, so it just is what it is. But you have to find 1, 2, 3, 4, 5, 6, 7, about 7 or 8 points to be able to graph it accurately. Okay, it's not a huge deal, but you have to do it. All right, now let's look at this one here. Same kind of deal. We've got x and y. I'm going to start with -3, -2, -1, -0. Wow, 0, 1, 2, and 3. Now we're using this function here, and then we'll put it on a graph. So the exponent goes right here. So let's come over here. It's put over here. So we've got y. That's what we're going to get out. We have 1 to the 4th to the x power, like that. 1/4 to the x power. It's this to that power. So if we put a -3 right here. This is where we're putting the x. So if we're going to take this to this power, what that is 1 to the -3 over 4 to the -3. And so we're going to flip that thing over. Do you understand? So this is going to be 4 to the 3rd over 1, because 1 to any power is just 1. 4 to the 3rd, 4 times 4 is 16 times 4 is 64. So this is 64. A little bit hard to graph. All right? So if we put a -2 in here, that's going to put a 2 right there. 16. If we put a 1 right there, it puts a 1 right there. That's 4. Anything to the 0 power is equal to what? Anything to the 0 power is equal to 1. All right? If I put a 1 here, I just have 1/4. If I put a 2 here, I have 1 to the over 16. Do you see the pattern again? If I put a 3 here, I have 1 over 64. Here's a 64, 64. 16, 16. 4, 4. That's 1. Do you understand the pattern that's going on with this? So we graph it. I know, you don't have to do this a lot, but you have to do it a little bit. I'm not going to be able to get this and this on here, because 64, I ain't going that far. I love you, but I'm not going to Mars. Actually, I'd love to go to Mars. So -3, 1, 2, 3, and positive 64. It's like up there somewhere, okay? I don't know. So I'm not even going to do that. That's too much. So 2 and 16. We'll put it up here somewhere. -1 and 4. Okay, it's coming from here. 0, 1. Okay? 1, and the y is 1/4. It's like here. And 2 and 16, it's almost on the line. So it's the opposite of what we did. It's coming down like this, and it approaches that line, but never reaches it. There's a word for that, but you don't care. So you see the difference in the two graphs. This graph here started over here right on the line and went up like this. That's this to that power. The bigger this number gets, okay, climbs like that. This is a fraction to that power. It flips it over like this. The bigger that number gets, the smaller this fraction ends up being, okay? You just have to try it, this, or whatever they give you. Put enough points in, 1, 2, 3, 4, 5, 6, 7. 7 here, We kind of took that one out because that's just way out there. You just have to try it and graph it, okay? It's not a big deal. In a graphing calculator, you enter those numbers and you hit equals and it shows it to you. But graphing calculator starts at about $100. So this one here is one of the problems on your system, a compound interest problem. It's using, the only similarity here is it's using the exponent key. This right here is the formula for compound interest. Write it down so you have it. It asks you to find it. I'm giving it to you because I'm a wonderful person. Okay? This says the amount after a certain number of years. N up here is the number of years. This is P, the principal, the amount you put in to start with. This is the interest rate as a decimal. Okay? So we have $8,000 at 9% for 15 years. I want to know if I put $8,000 into a savings account at 9% interest, compounded yearly, how much will I get back after 15 years? Okay, well, I just put my numbers in here. This will be 15. Now, I don't multiply, divide, do anything with that. That just tells me it's 15 years. The amount after 15 years is $8,000, because 8,000 is the P, the principal, times 1 plus. The interest rate is 9%. That's 0.09, like that. And it's going to be there for 15 years. That's right here. Same number here, like that. All right? So equals 8,000. This is 1.09 to the 15th. So you have to put that in your fancy-dancy little calculator. If I can enter it right, I'll get the right answer because that always helps, I've found out. Uh-oh. There it goes. Okay. Now, I'm not doing this yet. Forget this. It's just this. 1.09 on my calculator. First function, the XY button, and I put in 15 equals. All I got was this right here. And this is, for me, 3.64248,246. I'm going to round that off to the hundredths place. 64 times. Okay, so now since I rounded it off, I want to clear it off here and start over again. 8. If I just hit times, I'll use that whole extended decimal, and it makes a little bit of difference in the number. Times 3.64 equals. So here's what I get after 15 years. I put $8,000 in there. All I did is put it in the bank. They're paying me 9% interest. After 15 years, I go and I say, I want my money. Give me the money. Give me the money. Give me the money. And I have. I started with $8,000 and I didn't do anything. I just let it sit for 15 years. I get out $29,120. Not too shabby. If they want to know what the interest was, I just subtract 8,000. The rest of it is all interest. Okay, I hope you guys get this. Now, listen to me. I would strongly suggest you write this down. If you text me or want to call me and say, I don't get how to do this problem because I don't know how to find the formula, I'm going to say, well, you know what? Watch the video, and I'm going to hang up because I'm giving you the formula for compound interest. The money goes right here. That goes here as a decimal. This is up there. You add these together. You take it to that power. You multiply by that. There's your answer. If you take this and subtract it out of that, everything else is interest. This was the principal. The money, everything else is interest. The interest is like $21,000 worth of interest. Pretty good deal. I would take that in a heartbeat.